Hi, my name is John Krockmalny, and I've developed these visual tutorials to accompany any technical training format that might be delivered. In this presentation, we'll explore the test instrument called the multimeter. We will also cover the configuration of the multimeter in preparation for actual measurements. In this presentation, there will be 3 learning outcomes. Number 1, state the use for multimeters. Number 2, configure the multimeter to measure electrical properties. And 3, place multimeters in circuits for the measurements. Multimeters are electrical test instruments commonly used by technicians working in the electrical fields. These meters are used for measurement of electrical properties, testing electrical circuits, and troubleshooting electrical circuits. The most common use of multimeters is to measure voltages, resistances, and amperages. Sometimes these meters are used to look for continuity in circuits, which is another type of resistance measurement. Some multimeters can also measure temperatures and frequency. There are several manufacturers of multimeters, each with their own designs and layouts. Typically, all multimeters will come with a display where measured values are shown. Option selection buttons can be found on meters that allow users more functions for use in their measurements. Dial selectors or indicators are manually adjusted switches that users use for the measurement that they want to take. All multimeters will have leads and lead ports. Electrical property measurements are performed when the component being measured is touched by the meter leads, which are attached to the meter. The multimeter has a capability to measure electrical properties of voltage, amperage, and resistance. As we may already understand, voltage and amperage may come in either alternating current AC or direct current DC forms. Whether measuring AC or DC, multimeters can be configured to read both forms. The selector switch is what configures the multimeter for the intended property for measure. Notice that this meter has selector positions for voltage, millivolts, resistance, amperage, and milliamps. Configuring the multimeter for specific measurements involves a process or sequence of events to be applied before measurements are taken. In order, the multimeter configuration sequences are: number 1, consider what it is that is going to be measured. Number 2, set the leads for that measurement. Number 3, set the selector indicator for that measurement. And number 4, set the range you expect that measurement to be in. The first step in the multimeter configuration sequence is to consider what exactly is being measured. Does one want to measure volts, resistance, amperage, or continuity? The second step involves setting the leads for the measurement you wish to take. The black lead in this graphic will be placed into the black port marked COM. The red lead will be placed into the red ports marked A for amperage, V for voltage, or R and the Greek letter omega standing for resistance. Setting the selector indicator is the third step in the configuration of the multimeter. This dial switch is moved to V for voltage, AC or DC, the omega or the letter R for resistance, or to A for amperage, AC or DC. Setting the range is the fourth and final step in the configuration of a multimeter. The range sets the internal circuitry of the meter to accommodate readings in tens, thousands, and millions. The range could also set internal circuitry to measure tenths, thousandths, and millionths. Let's consider how to configure the multimeter to read voltage. For voltage measurements, we have to connect the meter to the component with its power supplied. Following the configuration sequence, We follow the steps in order. We already know what is being measured. It's the voltage. Setting the leads, we attach the black lead into the black port marked common. The red lead is placed into the red jack marked V for voltage. Setting the selector switch is the third step in the process. Move this switch to V with the sine wave above it allows the meter to measure voltage, alternating current, or AC. Moving the switch to V with the solid and dashed lines above it configures the meter to read direct current, or DC. To read voltages in millivolts, the switch is moved into that position. The fourth step is to set the meter range. The pressing of the range button moves the displayed decimal point over to the right one position. With this range being set, the meter can read in values of tens, thousands, and millions. Some quality multimeters come with an auto range function which automatically adjusts the decimal point position. Once configured to read voltage, the actual measurement can be performed. For voltage measurements, the meter is placed either across the source of power or across the load being measured. It is important to understand that when measuring voltage, the power of the circuit being measured needs to be applied. Circuit resistances can also be measured with multimeters. Again, we follow the four considerations when configuring the meter. Since we already know that it's resistance we want to measure, we perform step 2, setting the meter leads. For resistance measurement, the black lead is placed into the black port marked COM. The red lead is placed into the red port marked with either the Greek letter omega or the letter R. Both are indicators for resistance. Step 3 involves moving the selector switch to R or omega symbol on the dial face. The fourth step allows us to configure the range. The range determines if the displayed value is going to be in tens, hundreds, thousands, millions, etc. Quality meters will usually have their display having additional information for users. Here we see the Greek letter omega indicating the resistance measurement. The capital M is an indicator that the value is in millions. If there were a capital K, the value would be in thousands. Notice in this graphic, the load has been disconnected from its source of power. For resistance measurements, meters are placed across the load that has been disconnected from its power source. For resistance configured multimeter measurements, the meter's internal 9-volt battery provides for the power for the measurement. If this configured meter were placed into a powered circuit, damage of the meter could result. For amperage measurements, the meters are set up in the same sequence. For amperage measurements, the leads are positioned with the black lead in the black port marked COM. The red lead is placed into the red marked port, identified as MA for milliamp, or A for full amp measurements. Step 3 says to move the selector switch to the milliamp or full amp position. Notice the symbols above these letters involving the solid dashed lines and the sine wave. Step 4 requires us to set the range for the expectant measurement. Once configured for the amperage measurement, the meter is placed into the circuit in series with the load. Notice in this graphic, the power has to be supplied to the circuit in order for the meter to read its amperage value.